Good afternoon. I'm going to talk about data frameworks, data handling in Mathematica. I'm going to talk a little bit about sort of previous, what you can do in previous versions, and I'm going to concentrate on new features for version 10, with a focus on what's in version 10 rather than sort of aspirational. And there's lots of things that we're working on, but I'm going to focus on what we actually have. So I'm not going to give a demo of all of these because time's kind of short, but I just thought I'd put up some of the existing features for data, from small data processing up to large-scale data processing that exist in current Mathematica. And so here's just a couple of, this is the sort of thing that, maybe this is much easier with the new geographics system, but this was the sort of thing that Mathematica, I think, is very good at, is sort of integrating data and visualizations from different places. So this was a map that someone made, and they imported an SVG file. So that's SVG is an XML graphics format to get the outline of all of the counties in the US, and then they loaded a CSV file to get unemployment figures. So that was just the sort of example of the type of thing that you might do. Another existing data mechanism is the Hadoop linking functionality. So Hadoop is a big data infrastructure. It's for very big data, where the data is too big even to fit on one computer. So it's like bigger than terabyte data. So not only can it not fit into memory on a computer, it can't really even fit on one computer. So Hadoop supports kind of one algorithm, MapReduce. So it's definitely, any color you want so long as it's black. It's just one algorithm, but there are many types of algorithm. You can do an awful lot of data analysis with a MapReduce. Hadoop is absolutely not consumer software. It's very complicated to set up. It's experts only. Now we built a link to Hadoop for Wolfram Research to do analytics on our own website data. So we were using Hadoop, and then we built a link to the technology. And the things that we were really linking to were more the file system. So Hadoop has a distributed file system, and it also has a HBase, a database. So this is a NoSQL, so it's not a SQL database, it's a NoSQL, it's a distributed database, and that's part of Hadoop. We also made a way to run MapReduce jobs, actually writing the mappers and the reducers in Mathematica. Now, this is the value that Mathematica brings to here, I think, is worth remembering. So what Hadoop is good at is doing very large-scale data processing, taking big sets of numbers and then producing slightly smaller sets of numbers. And what we were finding Mathematica was very powerful was coming in at the end of that and producing visualizations, analysis on the output of Hadoop. And that's often something I think that people fall down at. I've visited other companies, and I visited some company, and they were running DNS servers in the United States. So just with their DNS data, they were producing, I think there's 50 gigabytes a day for every day as DNS resolution in the United States. And then they were running Hadoop jobs to look at patterns. The California traffic was being routed through Texas, and so that was a big problem. But then they had a real bottleneck in taking the output of their analysis and looking at it. And they had Java programmers writing GUIs and things. But they really wanted to sort of do different things every day. And that's, of course, is where Mathematica is very valuable. So it's very quick to put things up and explore things. So I think that's a way that Mathematica can come in very quickly to sort of analyze things. Right, so now I'm going to jump into some new technologies. Keep an eye on the time. Right, so some of the new features, these are things that are shipping in Mathematica 10. Of course, there's lots of other things I could have picked, but I've decided to focus on these things here. So I'm going to start out by talking about this new thing in Mathematica that we call association. So I talked about it in the programming talk, the language talk I gave yesterday, and association is a very powerful tool for programming because you can make something like a record or a struct or an object in Mathematica, so that's a new thing. In terms of data processing, it's useful because it's a data structure, so it's like a hash table, and it's good for sort of looking at, holding data. So let's just have a quick, we have this sort of angle bracket / notation, and I'm just going to load up association. So it's a little bit like a list in a way, so it has I can extract the parts, I can assign to it. So one of the things to remember, of course, is that each thing that appears on the left-hand side can only appear once in the association. So it's like a hash table. So the keys are unique. Now, one way to think about it is it's a little bit like a Mathematica list, except the parts have names. So they don't just have numbers that go from 1 to the length, they're given names. So here's kind of like a list, and we would say the first part is A, the second part is B, and here is the association. So here I'm giving the name is actually a compound thing. So I'd say the F brackets 1 part is A, and the G brackets 4 part is B. So that's a little bit like the way that it works. And if you want to make a mental map of how this behaves in the system, thinking of it as a list that has symbolic names for the parts is a good way of doing it. So with this, we can do some structural operations. So I can append to the association, so it sticks the thing at the end. I can pull out parts. So I have to use the key, this new keyword called key, and I can map over the association. So the map function applies a function to every element, and that's the same way that it works here. So not sure what that guy's doing here. Now we also have a thing, if you want your map to work with the keys in the association, we have a thing called association map, and that's what association map does there. And here's another new feature that's in the new version, is how this works with Mathematica pure functions. So one way of extract, so here's an association. Now the names of the keys in the association are strings, and strings are given a special status in associations. So I can look it up in the normal way by just applying the function. I could also use part, and when the key is a string, I don't need to wrap it in the key thing. But here's a nice way of working with it, is that I can refer to the name in the association when it's a string just by concatenating the A with the slot variable. So this makes some nice, concise, expressive syntax. Or here's another way of doing a map. So this is a concise way of working with the with association. Talked about this yesterday, but I'll just reiterate this. Association is it's very optimized. So I'm creating an association with a million elements. builds up quite quickly. Now what I'm going to do is make a copy. So I've got this points to an association, this points to the same one, and if I look something up, it returns the value. Now, if I make a change to the association, so I change an element, then that's changed that element, but the thing that was also copying to it has not changed. And so this has made a copy of this very large data structure it's not real time, there is a logarithmic, but it has a sort of tree structure. It's a clever algorithm that shares many common parts of the things of the data structure that it knows hasn't changed. So that means that it's immutable, which is a useful feature of the programming contract of Mathematica. Now, let's go and look at some more data handling. So this is association for data handling. Yesterday I gave some examples of association for programming. This is how I'm going to look at some data handling types of things. So for example, if I'm going to look up keys, so there's an A key and a B key, but there's no C. So if I look that up, I get this sort of missing thing that comes back. There's also a new function called lookup, so that by default that uses the thing, but I can give a default value. So if the key's not found, then it returns this default value. Now, let's look at here are some other useful functions for working with collections of associations. So I've got an association that has an A and a B, and I've got one that has just an A. So then there's a useful function called association union, and that coerces all of the associations to have the same structure. So in this one here, which is missing the B key, it adds a missing. So sometimes that's a useful sort of thing to have. When you're programming, you probably don't need that, but when you're doing data handling, this sort of thing is useful. And then there's the same sort of thing, union, intersection, that's same sort of thing. Now, another useful feature is this thing we call merging. So what merging does is I'm going to take these two associations and it's going to match up the keys applying a function to them. So basically what this is doing is sort of adding the values of the same key. It's a bit more illustrative to give just an arbitrary function f, so that's going to sort of wrap around the various, the various parts. And if there's a missing value, then it's just going to be sort of absent from the final thing. So if you wanted to know which parts were missing, you might use key union beforehand. So that's what I did there, key union, and then now I've able to pick out the things that were missing. So that's the merge function. We have this thing called join across. So this is a new function, new feature of Mathematica, and this is a little bit like an SQL join. So I've got two lists of associations. So each one of these is a little bit like, you could think of it a little bit like a table in SQL. And I'm going to join both of these tables on the A key. And so this sort of finds the keys that match up, and it produces a new row sort of concatenating the various parts together. So that's a little bit like a join in SQL, and as people that know about SQL joins know there's different sorts of joins dealing whether the data's missing in the first or the second or both, and you get sort of inner, outer, left and right joins. So that's a useful feature. Quite often, I think when you're doing data processing, things like this are actually really quite useful. And as I said, it's very optimized. So that's now. Here's another useful new feature is a grouping, group by. So what we're doing here, actually here I'm just applying group by to a list, and I'm saying group by the identity. So group by returns an association. So this is showing for each element in the list, it's applying this function to the sort of groups, to all the elements that have this sort of function. And here's another one. So if I apply this to, in a sense, what I'm doing here is I'm actually kind of making an inverse of the association. Now this group by is also, you can give this is the thing that creates the sort of connection between the things, and then you can have a reducing function. And so here I'm going to make here's a collection of random letters, and I'm going to put this into group by, applying the identity function, and then applying the length to all the things that are created, and then I'm sorting the output. So basically, this is what I'm doing is not completely efficient, but I'm doing counting the sort of frequency at which all of these, distribution, histogram of all of these letters in the output. And this is actually a MapReduce operation. So this is, if you want to do MapReduce functions in Mathematica, then this group by thing is the thing that'll do this. And we can sort of crank up the size of this quite a bit. And so I've made so it's now 2 million letters, and then I can apply this group by function, and so now, of course, we see this is much more uniform. So we would hope that the random integer should produce a uniform distribution, and we see that it looks much more uniform. And again, you see I'm plotting. If I put association into a bar chart, it does kind of like a sensible thing, showing the values. And then if I turn the chart labels on, I get the keys showing up down at the bottom. Right, so that's association there. So this is lots to talk about. I've got to keep going. Sorry if this is a whirlwind, but hopefully this will spur your imagination, and then you can study these things in more detail. Right. Now, another new feature I want to talk about, changing track, is to a new way that we've added to actually hold dates and times. And so this is a thing we call date object. So you give it well, that's not actually the current time, but it's, so the full form, it's date object. And the advantage of this is that this makes it easier to recognize dates in programs, because they have a head that says this is a date. There's a thing called time object as well. Previously in Mathematica, you would just work with a date with a list of 3 numbers. And that's kind of fragile. It might really be a 3 numbers. It might be a coordinate, in R3 or something. But so having this date object makes it, is more it defines what it is. So we have, we can interconvert with, you throw a date object into absolute time, you get, the number of seconds, you can convert it back to a date object, and the same with date string. Again, you can sort of interconvert all these things. Here's another thing that's pretty useful. So this just returns the current time. We have this convenient way to access elements. So we have this thing called date value, so we can ask for the year or the month. And it's much better to do this rather than doing, in the old days in Mathematica, you'd have to do, D1, something like that. And, this doesn't look very, it's not very readable. You go and look at this, it's not very literate. And one of the things about Mathematica programs is we want them to be literate. We want, when you read it, it's got to tell you what it does. So that's and then we also have a date object queue, that tells you whether this is, a valid data object. We can do comparison functions on data objects. So kind of nice, is one thing, dates are ordered. There's an ordering with dates, so we can say whether one date happens before another one. And so we can do like that and make a whole load of dates. And then we can sort. We can do sorting. So that's quite useful. And we have functions. We've had functions like these before, but we've sort of unified these a little bit. So I can do like differences between dates, or there's a date difference function where I can give the granularity, or there's a date plus. So here's 20 days from today is this. And these things can work with our calendar functions that we introduced in version 9, and those are things that know about business days and roundings and things like that. So that's all kind of a useful thing. Right, doing okay. Right, so report generation. I think this is another powerful data processing functionality, report generation template system. I'm not going to give a demo of this. John Fultz gave a nice demo. John's somewhere here. There we go. He gave a nice demo of this morning, so I hope you're all at the talk or you can look into this. But the useful thing about the report generation is that it's a very convenient way to construct notebook documents from a program. So you don't have to do low-level notebook programming. You just write, what's the best way to make a Mathematica notebook document? It's to do, Command N and use the front end to type it in interactively. And then the report generation fills in the parts for you. Right. Now, I want to spend the last part of my talk going over another new feature. So this is this thing that we call dataset. So this is a new way of handling data. Now, we've been working on a thing like this with different features and such like. It's tied into association and such like. We've gone through various iterations of features, and this is the initial round of the functionality. There's lots more we want to add to this, but this is what we've delivered in version 10. So I think this is kind of a powerful, nice new feature. So let's kick off by making a data set. So it's sort of, first of all, so I've made a data set, and this is one that it's basically, we can talk a little bit later about how you can construct this, but basically you can just pass in sort of various structures into data set, and then it goes and studies it and analyzes it. And the nice thing about this is it keeps, it's got rows. So this is like a table in SQL. It's got the sort of labels on the columns, and it's got the data. Now we can go back, and it prints out in some sort of informative type of structure. We can go back to the underlying expression structure by using the normal function. We can pick out something, so I can go to the first row and get the height value, and that returns the sort of data value there. Or I could pick out, for example, the value of all of the height of all of the rows and such like. Now, here's some things. So you might want to operate on your data set to do some selecting. This is a thing that's useful. So this is kind of like a functional version of select. So this is a select, actually, that you can apply to a so this is a what am I doing? I'm not quite sure what that's. Okay, that's.
Age must come on.
I don't have an age in there. You're quite right. I should do this. I shouldn't do that either. I should do this. There we go. Finally, right. I do type in the right thing. So this is a pure function. So I could do something like fun equals like that, and then I could apply this. So it's just a convenient syntax for sort of working with. Now, applying this to data set, I can put this selector inside of the data set. And then I could drill down further, so select a bunch of rows with my selector, and then pick out just one of the columns. Another, got to go super far. I can take the, so I can do, I'm not quite sure what I'm doing here. Let's just, I can say do plotting. So I can pass in the function. This applies to all the rows, and so this has the result of making a plot. Or I could choose, here I could come and choose columns. And I can give sort of options to the plot. And when you give the options to the plot, it knows, kind of what you're doing. So this is kind of the idea, is a function is going to apply to the entire data set. Oh, I know what the problem is. I've got a definition for function. Right. So if I put just an arbitrary thing into a data set, it applies that at each level. So an unknown function is not very useful, but I could, for example, put in length to get the length number of elements in the data set. Or here, I'm going to get all of the elements. Right. I'm not running out of time, so I'm going to have to jump over some of these. Or maybe I'll go back. And so data set, there's different versions of data set. So it can be just like a list of values. This is like a vector. Or it can be a list of values where each value is different. So that's kind of like a tuple. And then with association, I can have a struct where each element has a different, one's an integer, the other's a string, or I could have it be an association where each element is the same, like an integer. So that's like a named vector. And of course, we can recursively create compound data sets. And it's not just tables, it's any arbitrary structure. So this is like a NoSQL type of data handling functionality. So I've got something like that, but I could also build up, here's something where I've got departments, but each department has its own substructure. And I can use the data set functionality to commands to sort of drill down and work on it. So creating these, there's this new function called Semantic Import that I can import. So I can just say automatic and it figures things out. But what's kind of useful is I can also give it sort of, if I know what the types of the individual columns are, I can load things like that. I have to keep going fast. Here's another example of data set. So I've got two. This is using join across, but now this is join across operating on a data set. So I've got two tables. So I've got each table has a common ID, and I'm going to do a join across where I give it the ID, and it produces another data set where it sort of joins things together. So these sorts of things are built in. We can sort of chain these commands together to do interesting things. Here's just my last slide. So this is showing the grouping functionality. So I've got here rectangular data, and what I want to do is I'm going to do group by, again, a functional. And so this has generated a new data set. Maybe if I look at the normal structure, this might help to understand. So I've pulled out all of the common names into sort of separate lists. And then with this thing here, here's a nice sort of chaining thing. I can do grouping, and then on the next level down, I can do the merge operation using the mean as the reducing function, and then say I just want the open and close. And so this is a very sort of efficient syntax, basically, for grouping, merging, and then pulling out just individual items. So this syntax is more of a chaining syntax. So if you're familiar with SQL, SQL has commands like the select command where you can do grouping and applying certain mathematical functions and such like. But in one command, this is a little bit different, and you're giving a chain of like a pipeline of commands to go through. Now, this pipeline is interesting because we can actually optimize it for something that we don't have finished in this version. But if the data was actually living in a data file, we'd be able to read parts of it, pipe it through this sort of chain of things, and come out with the output, but in a way that was particularly optimized. That's not a thing that we finished in this version, but I think the functionality is still useful. So just going to quickly summarize, and then I'll finish. So I was talking about data handling features in Mathematica. I looked at some of the existing features and pointing out the Hadoop link. If you have terabyte data, that's you can integrate Mathematica in the tool chain there. And then I looked at new features. So I looked at association, data object, mentioned report generation, and then spent some time looking at this data set. Now, I think this data set is going to be an exciting new feature that we'll be developing in the sort of upcoming future. But what's there is useful. And for example, in the previous talk, I think it would have been interesting to try to use some of the data set. Then what it can do is exactly what Mathematica should do, is it would mean that you could focus on the algorithm that you're applying rather than the sort of data handling techniques. So you could do what you might be interested in the data handling, but you probably know lots about the algorithms, and that's what you really want to focus on. So it takes some of the sort of boring detail out of you, from having to do that. Anyway, I'll wrap up with this, and I can answer some questions maybe if we have time. So.